So for 11.3, we're actually still working with the binomial theorem, but we're using it to find a certain term in the expansion. So they're going to now ask us, what's the fifth term? Or what is the... So we're just looking for one specific term. Okay, now here's a short description, again, just to remind you of Pascal's triangle. Pascal's triangle is shown below with its entries represented by combinations. Oh my gosh. And its entries represented by numbers. The first and last numbers in each row are always 1. Every number other than 1 is the sum of the closest two numbers in the row directly above it. Okay, so here's Pascal's triangle. This is the one that we worked with yesterday on the right, correct? Okay. What we are going to be working with today are the numbers represented as combinations. Okay, so right here, n is what is the binomial exponent. So where here it says n equals 0, that means that you have a binomial raised to the 0 power. Okay, and then our first number is 0, combination with 0. When the exponent is 1, so binomial raised to the first power, we have 1 combination 0 for the first term, 1 combination 1 for the second term. Are you guys seeing a pattern here? When my binomial exponent is 2, so my exponent is 2, I have 2 combination 0 is my first term, 2 combination 1 is the next, 2 combination 2 is the next term. What about when my binomial n equals 3? So my exponent is 3. First term is 3 combination 0. Next term is 3 combination 1. Next one is 3 combination 2. And the last one is 3 combination 3. And I guarantee if we were to do these combinations, we would get the numbers in Pascal's triangle. So this is just a different way of representing them. Okay, next one, if I have a binomial raised to the 4th, so n equals 4 here. First term is 4 combination 0. Next one is 4 combination 1. 4 combination 2. 4 combination 3. 4 combination 4. So the first number in the combination is always going to be the exponent. First term starts at 0, and the last one ends with the exponent as well. Make sense? Okay, so we're going to use this in example 1 to find the coefficient of x to the 5th in this expression, x minus 3 to the 7th. So what we did, or what I did here for you, is I already listed the combinations, which are the coefficients. So my first coefficient, because I'm raising it to the 7th power, is 7 combination 0. The next one is 7 combination 1. Next one is 7 combination 2, 7 combination 3, and all the way to 7, right? Okay, these are your coefficients. These are the terms of Pascal's triangle. So all we're going to do first is fill in the blanks with the exponents. Okay, so I have, for my exponents, here's my coefficient. So my exponent is starting with x to the what power? 7th power. Just like we did earlier today and yesterday. So the second term has x to the 6, and my b term in this case is negative 3, so negative 3 to the first. We're just filling in the exponents right now. These are your coefficients. Okay, so it's the exact same thing we were doing before. So this is x to the 5th, negative 3 to the 2nd, x to the 4th, negative 3 to the 3rd, x to the 3rd, negative 3 to the 4th, x to the 2nd, negative 3 to the 5th, x to the 1st, negative 3 to the 6th, and then no x's and negative 3 to the 7th. So all we did was fill in the a's and b's because these are our coefficients here. Okay? That's all we did so far. Yeah. The good news is, what is our question asking? for the coefficient of just the term that has x to the 5th. So do I have to do all of those combinations? I only have to do the one that has x to the 5th. Which one has x to the 5th? The third one, right? Okay, so that's the only one we have to deal with. So what is 7 combination 2? Do you guys remember? 7 factorial over 7 minus 2, which is 5 factorial, 2 factorial. That 5 is going to cancel, so we're going to be left with 7 times 6 all over 2, or 2 times 1, which gives me 21. Okay, now that's not our answer because the coefficient of the term, so let's write, but the coefficient of the term is, we have to take the combination that we just found and we have to plug it back in because there's a negative 3 squared in there, right? So that's actually going to change our coefficient when we multiply it all out. So, but the coefficient of the term is, this is going to be 21 times x to the 5th times negative 3 to the 2nd, so I just plugged it back in, which is going to give me what? 21 x to the 5th times positive 9. What's 21 times 9? 189. So my entire term is 189 x to the 5th. They just want the coefficient, so what's my answer going to be? Just 189. So the coefficient is 189. But we do have to plug it back in and do the extra work just in case there's more integers to multiply by. So they want the coefficient of the final term. Okay? So similar to example 1, example 2 asks us to find the coefficient of x to the 3rd. So we're only concerned about the term that has x to the 3rd in it. Of the expansion 3x plus 2y, all of that to the 5th power. The first thing I want to do, okay, so what I want us to do is first write out all of the combinations and fill in the blanks like we did in the previous one. So if I am the whole binomials to the 5th, what's my first combination? 5 combination 0, blank, plus 5 combination 1, blank, plus 5 combination 2, blank, plus 5 combination 3, blank, plus 5 combination 4, blank, plus the last one, 5 combination 5, blank. So we just filled in all the blanks, or we want to fill in all the blanks now. Okay, so what is going to be my first term here? 3x to the 5th. Next one, 3x to the 4th and 2y. Next one is 3x to the 3rd, 2y to the 2nd, 3x to the 2nd, 2y to the 3rd. Next one is 3x and 2y to the 4th. And the last one is 2y to the 5th.
Wait, why do you go that far if you just stop at x3?
I just wanted us to practice filling them in. Oh. Okay? So we only care about the term that has x to the 3rd in it. So which one of these has x to the 3rd in it? 5 combination 2, this one. So the first thing we have to do is find 5 combination 2. 5 combination 2 is equal to 5 factorial over 3 factorial, 2 factorial. The 3 is going to cancel, so we would be left with 5 times 4 all over 2, which gives me 10. Now we're not done. This is the coefficient that we're multiplying this whole thing by, so we have to plug it all back in. So this is going to be 10 times 3x to the 3rd times 2y to the second. Okay, that's going to give me 10 times, what's 3x to the third?
27.
27x to the third times 4y to the second. Okay, so that is 10 times 27, which gives me 270 times 4, 1080, x to the third, y to the second. This is the whole term. We only want the coefficient, so my answer is 1080.